Hey guys, welcome to another VATSIM video here on the AviationPro channel. In this video we're going to take a look at some of the basic flying, navigation and flight management skills you need for flying on VATSIM. If that sounds interesting, stay tuned. So guys, just like preparing a flight plan, actually being able to fly your aircraft on the VATSIM network is very important as well. Because you may understand, if you're flying on VATSIM, you're going to add communication to your flying, and if you don't know how to fly in the first place, that's going to be kind of troublesome. So actually flying is very important that you are able to do that properly before you start to fly your first flight on the VATSIM network. So you need to be able to make turns, climbs and descents without deviating too much from your assigned altitude, and you need to be able to navigate through the virtual skies. So whether that be flying a general aviation airplane or a IFR airliner, for example, with all those aircraft you need to be able to fly through the virtual skies and navigate and follow ATC instructions. So in this video I will take you through some of the basic concepts regarding these items, and first of all take a look at some of the basic flying skills you need. So I'm going to be showing you that in a general aviation aircraft, but the same applies to any aircraft that you fly on the VATSIM network. So let's take a look. So guys, welcome into the Beechcraft Bonanza here at St. Martin Airport, and I'm just going to show you some of the basic flying techniques that you really need to master for flying on VATSIM. So one of the first things that you actually need to be able to do is be able to taxi. So when you have your aircraft loaded up at the gate and when you push back, or maybe if you're flying a general aviation plane like this, you don't need to push back, but you need to know how to taxi. So make sure you get a kind of a feeling what it's like to taxi, because in the beginning it takes some time to get used to. Now if you're flying a general aviation airplane like this, you will just use the rudder to move your aircraft. If you're flying an airline, you could use a steering tiller, for example the Z-axis on your joystick, to move the nose wheel. So I have just a very basic setup. The aircraft has just normal fuel level, and I didn't really configure anything. I'm not flying on VATSIM obviously, and the weather is set to fair weather, and that's kind of a good practice to make sure you get the feeling of what your aircraft feels like. Alright, so just take the time and practice in normal conditions first. Alright, so we'll just line up on the runway. As you can see, we taxi along the beach here. And when you take off, it's important to realize what the wind is. In this case, the winds are calm, so it doesn't have any effect on the aircraft. But if you're flying on VATSIM and you will be using real world weather, so make sure you know what the wind condition is, because based on the wind condition you might need to alter your control inputs. For example, if the wind is coming from the left, then we need to give some left aileron input, and we probably need to push some right rudder in order to stay aligned with the center line of the runway. Same for crosswind on the right, we probably need to give some right aileron and then use left rudder in order to stay aligned with the center line of the runway. So I'm just gonna fly a small traffic pattern here at runway 10 at St. Martin, and this is a very good way to practice flying your aircraft, whether that be a general aviation airplane or even an airliner. You can just practice it offline, fly a lot of these traffic patterns, make a lot of touch and goes, and even if you want to get used to communicating to air traffic control while flying, actually flying a traffic pattern is one of the most simple forms of flying that you can do to combine with the phraseology that you require for such traffic patterns. So if you want to practice that, make sure you look up some VFR phraseology for flying traffic patterns at your local airport, and then you can just apply a very basic flying maneuver, flying a traffic pattern without having to worry about a SID star or any other complications that might have added to your route. And then you can just get used to pushing that push to talk button on your Yoko joystick while flying the aircraft. So I'm just going to take off right now. I've not set any flaps. Runway's long enough, so I'll be able to just take off. And there's a right hand traffic pattern here at St. Martin, and usually traffic pattern altitude is or 800 or 1000 feet above ground level. Now the elevation here at St. Martin is about 14 feet, so our secret altitude will be 1000 feet. So I'm just going to be flying 1000 feet here on the altimeter, and the QNH is set. So let's take a look at the takeoff. We'll just take off this airplane. And this is just something that you can practice, right? I mean, there's not much I can say about that right now. And we probably already have to make some corrections, so make sure you just give constant small corrections when you're flying your aircraft. And don't give any wild inputs or anything. Just take it easy, okay? So as you can see, we're aligning pretty well with the center line. And yeah, we're reaching about rotation speed right now. And there we go. I'm going to put the gear up. This aircraft has a retractable gear. And we're just going to take off and climb to 1,000 feet and probably make a right turn. And very important when you're flying aircraft, make sure you trim the aircraft. If I let go now, as you can see, the nose already goes down. So if I am constantly pulling on the yoke like this, I just use the trim to relieve the pressure of the yoke. And that's a very easy method of flying. It really makes sure that you don't have to put too much pressure on the yoke. So I'm just going to start a right turn here, I think in between these hills. And you might want to look up for your airport what the standard traffic pattern is, what it looks like. And as you can see, we're approaching 1,000 feet, so I'm just going to reduce the thrust, well, the throttle a little bit on this airplane. And just going to fly a standard traffic pattern. And you want to make sure when you're flying that you stay, within 100 feet of your assigned altitude. So 100 feet or above or below. Of course, you want to try to stay at 1,000 feet exactly, but it takes some practice. All right. For me now as well, I'm kind of too high, so I have to adjust a little bit by reducing the thrust and maybe giving some forward trim. And just keep an eye out also. Like right now, we're on the crosswind leg of the traffic pattern, and we're now going to turn right to the downwind leg basically, and I'm still too high, so I have to correct. So just make sure you make small adjustments and that you're staying at your assigned altitudes. That's very important. As you can see, when I make this turn, I'm already losing some altitude, so I have to correct for that later when I probably get out of the turn. So with the traffic pattern, it's pretty easy. You can just kind of rely on your visuals. You could also use some instruments. For example, you can use the heading indicator to make sure you're flying the opposite heading of the runway you took off from. So we were flying on runway 10. So if our heading is 280 right now, we're flying basically parallel to the runway. And if we look outside, that's indeed the case. So that's good, and then we can just keep it there. So when you're practicing with your aircraft, don't be afraid to just try some wild maneuvers. It's a sim, right? You can just kind of get a feeling, hey, what does this aircraft feel like? Alright, and then based on that you can kind of determine what kind of input you should give to this aircraft. Of course, the passengers in the real world would get very sick right now, but it's a good way to kind of get an idea of how your aircraft responds. And you can do that at different, different altitudes, different speeds. So you can kind of get an idea what this aircraft feels like. And also how to correct. For example, alright, I'm now way too high, so I'm gonna have to correct. I'm gonna descend to 1,000 feet again. And just stabilize the aircraft. Being able to stabilize the aircraft is actually very important, right? So I'm just gonna descend the aircraft back to 1,000. So reaching 1,000, I'm gonna slightly pull up the nose and add a little bit of throttle. And then just relieve the pressure of the yoke by using the trim. In this case, the trim up command. And then we should be pretty good to go. And also make sure you look outside, especially when there's just visual conditions are good. Then you can just look outside a lot and use the actual horizon as a reference. Alright, so as you can see, the aircraft is pretty stabilized right now. We're almost at 1,000 feet, so which is the correct circuit altitude, and we're good to go. So we might be we're now on the downwind leg of the traffic pattern. We might want to turn to the base leg right now and just practice turns. And using a traffic pattern with a left hand or a right hand traffic pattern, you can practice turns. And the thing about turns is that you be able to make that turn while keeping your altitude. So if I'm going to make a right turn now to the base leg, of course the nose is going to drop a little bit. And I need to correct for that by pulling on the yoke slightly so that the vertical speed right here doesn't change that much. Alright, and then we can just fly heading north basically, which is on the base leg for this runway, and just take it nice and easy, you know, and then just roll out, and then you can relieve the pressure from the yoke again, or the trim if you're using it in the turn. And then we can look outside again. Okay, what's our reference with the runway? Okay, there's the runway. It looks like we are below the glide slope. You can see the poppy lights right there, the precision approach path indicators. So we're still below the glide slope, so we don't have to descend yet. I think I'm going to put down some flaps on this base leg, and then I'm going to start the turn towards final. Again, by looking outside, and if there's any huge fluctuation in your vertical speed zone, don't be afraid to correct, right? So don't be afraid to push that yoke or joystick in order to correct for any fluctuation in your vertical speed, for example. So as you can see, we are pretty well aligned with the center line, it seems. I'm just going to roll out the aircraft again, and we're back at 1,000 feet, and then using the precision approach path indicators, the poppy lights, we're gonna make sure we are on a nice glide slope down to the runway. So I'm gonna put the gear down. As you can see, I'm not using any configuration here. I'm just flying the aircraft, and even if you're flying a 737, you know, leave all the configuration, just fly the thing and kind of get a feeling of what it's like to fly that airplane. It's super important, alright? And you can practice these traffic patterns very easily. It doesn't take much time, as you can see. My traffic pattern was kind of long right now, but you can make the traffic pattern a lot shorter and be able to make a lot more touch and goes, alright? Okay, so I'm gonna put down full flaps. There we go. And with the poppy lights, you want to make sure you have 2 reds and 2 whites. I think you might know about this already if you did some flight simming before, so just make sure you're on that nice glide path, and just make sure you have a steady descent. And again, make sure you use the trim to trim down the airplane, you know, so you don't have to pull on that yoke too much when landing. So again, depending on the wind conditions, your angle to the runway might change a little bit. So the crab angle, so where your nose is pointing at in relation to the track that you're flying. But in general, just make sure that you're flying towards the runway, and then when you're about 20 feet above the runway, for example in the 737, then you can take out the grab angle and make sure that the nose is aligned with the center line. Alright? Okay, so we're a little bit high right now. Again, just make small corrections, but also don't be afraid to make larger corrections if you need to. But we're now pretty well on this glide path. As you can see, we're doing nicely. Don't have to do too much correction right now. And we're going to make a full stop landing in this case. If you want to, you can just make a touch and go and do the same traffic pattern over and over again, and do that for every aircraft that you fly, so you really get the feeling of what it's like to fly the aircraft, make turns with that aircraft, things like that, and of course make landings with that aircraft, because if you're going to disconnect the automation, you want to be able to know how to land that airplane, right? Okay, so we're approaching the runway. What you want to aim for usually is these white blocks on the runway, the touchdown zone. That's where you want to land the aircraft, especially if you're flying an airliner. For a general aviation airplane like this, it doesn't matter that much. And at the last moment, I usually don't look at the poppy lights too much, because they kind of become less accurate at this stage. So I'm just gonna aim for the touchdown zone, and then slowly bring back the throttle and flare the aircraft a little bit, and then we can put it down on the runway. There we go. And we'll just brake the aircraft again while staying on the center line of the runway. The brakes might be a bit sensitive on your airplane, so make sure you keep that in mind. So now that you have a bit of an idea of the flying skills you need for flying on VATSIM, let's take a look at some of the navigation and flight management system skills that are required. Of course, you want to be able to follow ATC instructions, be able to follow SIDS and stars, fly an ILS approach, fly direct to a waypoint or a VOR station, things like that. And I'm going to be showing you that using the Boeing 737 by PMDG, I think one of the most popular products that people fly a lot on the VATSIM network. But the same navigation principles also apply to general aviation aircraft or another type of airliner like the Airbus or the Embraer, whatever. But I'm going to be showing you this in the Boeing 737. It may be a bit different in your aircraft, but just keep in mind the general principles regarding these navigation and flight management system skills. So let's head into the cockpit of the Boeing 737, and I'm going to be showing you all these navigation and flight management system skills using my example route from Amsterdam to Riga. In the previous two videos about charts and flight planning, I also used this route as a guidance, and I'm going to be using the same flight plan and route in this video. So let's take a look at navigation and flight management system. So welcome to the Boeing 737 cockpit. We're going to take a look at the flight management system in particular in this phase of the video. And again, as I said in one of my previous videos about add-ons, it's very wise to have an add-on airplane which with a flight management computer or system like this one. Okay, you will see why as we're going to fill in the flight plan and all things like that. So let's take a look. I'm going to show the flight plan to you guys. And we have here the flight management system of the airplane. So I'm going to quickly run you through it. I'm primarily going to focus on the route and the navigation part as we're going to fly. But I also just want to show you how I usually program the FMC in the Boeing 737 at least, so you kind of have an idea. In general, you want to make sure that in your airplane you load the correct amount of fuel for your flight plan. So in this case, if we look at the flight plan that came for us today, we can see that the release fuel, that's the fuel that you want to take with you, is 8,255. So I'm going to enter that here. And as you can see, the aircraft becomes a lot lighter. And then the payload, so you want to enter the zero fuel weight in here. So the zero fuel weight for us is 56.736. And we put it right there. Of course, you can also put in the amount of passengers and the amount of cargo exactly as to your flight plan, but as long as you have the correct zero fuel weight, that's most important. Alright, then we're going to take a look at the FMC functioning itself. So we can first start off with the route page where we're going to fill in all the flight plan information. So we're going to be flying from Amsterdam, which is the ICAO code here. Expected runway is 24, as you can see on the flight plan. We have runway takeoff 24, we have the takeoff data here, and we also have a departure route out of runway 24. So I planned for runway 24 in PFPX. Again, if you want to see my PFPX tutorial video, make sure you do so you know what I'm talking about exactly. Now if you are using PFPX but also SimBrief, there are options to export your route. And you can do it this way. You can just go to the export function. Then what you have to make sure is that the proper file path to your flight simulator is correctly selected. And then you also have to make sure that one of your add-on airplanes is selected in the list below, so that it knows where to export the flight plan. And then you just click on save, and then that route will be exported. So technically I can put in that route right here. So I put the first ICAO code of the departure airport, and then the ICAO code of the arrival airport, and then 01, because that was the name of the route. And then I put that in the company route, and then it fills in all the waypoints, the SIDS and the stars that I planned automatically in the flight management system. So you can put that right here. I'm not doing so. I'd like to show you how I do it manually. So I'll just skip that for now, but just so you know that that function is available, so you can easily put in all the waypoints, which is especially handy if you have a very long haul flight and you don't want to put it all in manually. Then the destination, put in the ICAO code of the destination. Echo Victor Romeo Alpha. Flight number, you can just put in whatever you want. I just picked some kind of random flight number, it doesn't really matter as long as you have also the same flight number that you connect with on the VATSIM network. Then usually the next thing I do is select the departure route. So in this case runway 24 is selected, and we're going to fly the Andik 1-0 departure. As you can see here, it's at the beginning of the route, and that will take us to the first waypoint Andik. Alright, so that is in there. You can also look at the charts to see exactly how this departure route looks. And it's very important to take a look at the lags page and make sure that all the restrictions are correct once you fill in the weight data later on. So let's take a look at that later. So we have ONDIC, and then just fill in the flight plan. So from airway to waypoint, and then another airway to waypoint, all the way till your last waypoint basically. So we fly from ONDIC via Uniform November 873, Uniform November 873 to Juist waypoint. Then we fly from Uniform Papa 729 to the Delta Hotel Echo waypoint. As you can see, there's a step climb involved as well, but I'm just not going to pay attention to that now. I'm just going to stick to the routes. So because there's a step climb, actually I can just go, because I'm ignoring that, I want to stay on my original flight level 370. I'm just going to put in waypoint Dosur right here. So that's the end of that airway. As you can see, you go from Uniform Papa 729 to Delta Hotel Echo, and then via the same airway you end up at Dosur. Then next we fly direct to Nislo. So that's not via an airway, which is possible. It might happen that your flight plan comes up with a route that does not include an airway through the entire route, so it's very much possible. And then direct to Orvix. There we go. And then you can also select an arrival if you want already. I always like to do that. So ILS runway 18. It's going to be the Orvix to Alpha arrival, or the star, as you can see. It's also in here. And then I know from experience from my last VATSIM video, full flight, that the transition is good in. Okay, so just so you know that the transition, as I talked about in the charts video, takes you from the star to the ILS of the runway, basically. Okay, so if all the routes in there, we can activate and execute that. And then it's important to fill in some performance data in the aircraft. So we have the zero fuel weight already. Then reserves, I usually take a look at my summary for that. And I usually take as reserves the final reserve fuel and the alternate fuel. So in this case that's about 1 plus 1.4 roundabout. Let's make it 2.6. There we go. And the cost index is something that you fill in with your aircraft as you add an aircraft to the aircraft database. So for me that's 30. And the cruise altitude for this flight, as I said, is flight level 370. Cruise wind, I usually put in the wind at top of climb here, so that the top of climb here, or so that the top of climb is accurately calculated. So in this case we have here top of climb. As you can see, there's some information about the waypoints here. For example, we can see what flight level, the temperature at that flight level. We can see the wind is 307 at 019. And then we have some more information about this waypoint. There's a lot of information on the flight plan that we can enter. For example, the true airspeed to ground speed as well. Then the 17 and the 663 are the distance flown and the distance remaining. Then the fuel remaining and fuel used, things like that. And then which lag, and then how much time you've passed into the flight, things like that. So you can kind of keep up during the flight how much fuel you're burning. If you're not burning too much, then you have to, because if you're burning too much, then there's something wrong. But what you have to fill in here in this part of the FMC is the top of climb outside air temperature, and in this case it's minus 54. So we'll enter minus 54, and the transition altitude, as said in the previous video, you can find on the charts. And in this case for Amsterdam at runway 24, this is 3,000 feet. Okay, I'm just going to execute it off, and then we can select the takeoff thrust. Now I've calculated a reduced takeoff thrust using PFPX and TopCat. So as you can see, I have here an assumed temperature of 36 degrees and the rated takeoff thrust number 2. So we'll just select 36 degrees and then takeoff 2. First select takeoff 2, then 36. There we go. And then we have a reduced takeoff thrust, which will help us save the life of the engines a bit better, and then also reduce climb thrust. Then takeoff page, we're going to enter flaps 5, and we can right click on this line select key to get the accurate center of gravity, and we put that in right here. And then in the flight plan we have the V-speeds. It also comes up with V-speeds itself, the flight management system. Usually they are the same. In this case they are 140, 140 and 145. So V1 is the speed where we decide whether to continue the takeoff or not. Rotate is the speed where we gonna rotate the aircraft and actually take off from the runway. And 145 is the safe climbing speed. That's V2. Alright? So that's the basic idea of how you program the flight management system. And you want to make sure that you cross-check with the charts whether your route's correct. Okay? So this is a very important part of your departure and the navigation that you have to do during the departure. So you have to look at your charts to see whether your route's correct. So we assume we actually received the UNDIC 1 share departure from air traffic control. So now we're gonna zoom in on that departure and see if this is correct. So the first waypoint we head to is indeed Echo Hotel 005, and which is 4.2 DME from Sierra Papa Lima. So what you can do is tune in the Sierra Papa Lima VOR in the navigation radio. So 108.4. Don't worry about my engines running, by the way. I've just left them running for this video. It doesn't matter that much now. 108.4. And as you can see, it already draws a line on the navigation display. But if we put this switch to VOR1, you can also see the distance from the Sierra Papa Lima VOR. And it's always good to tune those VOR stations so you have an extra sense of your position around the airport and during your departure. So at 4.2 DME from the Sierra Papa Lima VOR, we're gonna actually make that left turn to Echo Hotel 008, and indeed that's in there. A speed restriction of 220 knots. We can confirm that in the flight management system. Indeed, as you can see, this magenta 220 indicates that there's a speed restriction, and if we follow the VNAV profile using the VNAV function, that will be alright. And then eventually another left turn inbound Pampas VOR, and that's another VOR station that you could tune in the second navigation radio, for example. We fly inbound that, and then we can fly that outbound towards UNDIC. Alright, so just make sure all the restrictions are there. For the SITs in Amsterdam, in this particular case, there also is a general restriction of having to climb to flight level 60 before you climb any further. So this restriction is not in there because it's not bound to a specific waypoint, but in order to achieve that, we're just going to select on the MCP, we're going to select 6000, so that we're sure that the aircraft does not climb further than 6000 feet or flight level 60 during the departure, right? And also in the MCP you can fill in some other data. For example, the V2 is usually put in here, 145, and then the runway heading that should be about 238. Yeah, 238. And then here you can enter some courses. For example, we're gonna fly Pampas outbound 105 or 015 at some point, so you can just put that here. And maybe an ILS course if you need to divert to a runway that you already have an ILS tuned in there. Things like that, right? So that's the basic idea how you set up the flight management system. Let's take a look at the actual departure. So we've now arrived at the runway 24 at Amsterdam. As you can see, it's very rainy outside, which makes for an interesting departure. So the thing we want to do is we want to fly this route that we entered in the FMC as accurately as possible. So make sure, again, you cross-check if all the information in the flight management system is correct, if all the restrictions are there, if all the waypoints are in there. And basically, especially on your very first VATSIM flight, you can let the autopilot do the work. In this case, I'm going to hand fly for a little bit, but you will find that if you add communication to it, and if it's going to be very busy on the network, it's going to be difficult to pay a lot of attention to the flying. So actually, the autopilot will come of great use when you eventually do fly on the VATSIM network. Alright, so in the Boeing 737, this particular for the Boeing 737, you want to make sure that the flight directors are on, that the autothrottle is armed, and we're going to use LNAV mode. So now most aircraft, like the Airbus as well, have some kind of nav mode where you follow the lateral navigation basically. So it follows the route that is displayed here. For the vertical navigation you can use different modes. You can use VNav. VNav will try to follow the profile that's entered in the FMC as accurately as possible. It depends a bit on which SID you use. For example, if you have an SID with a lot of restrictions, it's wise to use VNav because a VNav system will automatically follow those restrictions. But on other SIDs, for example on this one, I don't have to engage VNav per se because I just have to climb to flight level 60, wait there and then see what comes up next. But it really depends a bit on the situation. But just so you know that VNav is there to follow the flight path, the vertical flight path accurately as possible, and the speed as well. We have some other modes, for example level change. It will climb on a selected speed here on the MCP. So for example, if level change would now be turned on, then the aircraft will try to climb at the highest rate as possible while still maintaining a speed of 145 knots. Or you could use vertical speed mode to determine your descent or climb rate yourself. Anyways, let's go ahead and line up on the runway. LNAV is already armed, so that will automatically engage. And on the Boeing 737 you have to activate something called toga mode, and there are other aircraft who have similar mechanisms, so it will just activate the takeoff mode basically, and it will make sure that the thrust setting is set to the reduced thrust setting that we've entered in the flight management system. So if I would push up the throttles right now just like this, it will just go to maximum thrust, which is absolutely not necessary. So just take it easy. Again, practice this offline. Oh, as you can see, it has stopped raining, so that's pretty good. Oh, it's raining again. Just for a short bit. Anyway, so what matters here is following the route, so we're just gonna take a look at that. I'm gonna advance the thrust levers, and I'm gonna hit the toga button, and just focus on the takeoff for now, alright? Okay, we've set the thrust. See, the aircraft is accelerating. It's raining a lot. Just monitor the speeds during the takeoff. You pull out 80 knots usually. 80 knots. And on the primary flight display you'll be able to see the V1 and the V rotate speed, which in this case are the same at 140 knots. And in that moment we're gonna rotate the aircraft, provided we have set the correct trim setting. Rotate. And of course you also have to call out V1. Then we can put up the gear. And as you can see, LNAV is already armed on the primary flight display. So I'm now already following the lateral path, basically. And I'm still flying manually at this point. And I just want to make sure that during this SID I follow the profile and the SID as accurately as possible, even when hand flying, alright? Of course, it depends on the wind and weather conditions how accurately you can do that, but as you can see, it's going pretty well. There's not much turbulence around. So I'm just gonna climb. I'm just gonna pretend air traffic control hasn't said anything. Actually, in Amsterdam, I have to go to the departure controller myself right now, but I'm just gonna pretend we first have to go to flight level 60 because we have not received a higher clearance yet. And if air traffic control didn't say anything yet, just don't go to a higher flight level, alright? Another tip I'd like to give is align your heading buck so that when ATC does give you vectors at some point, you may never know that you can easily select heading select mode. Alright, so we're in a left turn to the next waypoint. Again, make sure you have the SID chart next to you so you actually know where you are on the SID. And at some point you can kind of start accelerating. So in this case I'm gonna just select a higher speed, flaps up speed for example. And I'm gonna slowly accelerate. But I will make sure that I'm not gonna climb further than flight level 60. I'm still flying manually at this stage. You know what, let's engage the autopilot. Autopilot A engaged. Command A, and I'm gonna select flaps 1. As you can see, I'm now in level change mode, so it's trying to keep that speed, which I've set to the flaps up speed. I'm gonna put up the flaps right now. And we have passed the transition altitude. We've passed 3,000 feet, so we now have to move from the local QNH, which was 1001, to the standard QNH. And we do that by pressing this button over here. So I'm going to engage VNAV right now to further accelerate the aircraft. And in the Boeing 737, the VNAV system will not climb further than the altitude selected, or not descend further than the altitude selected. Alright, so it will now just level off at 6,000, as you can see, which actually gives us some time to accelerate, because we can just accelerate to 250 knots below flight level 100, and above flight level 100 you can climb or you can accelerate further than through 250 knots. So, and usually that's already selected by default in the flight management system. Okay, so we're flying the SID nicely. As you can see, we're gonna make the next turn. Actually, I'm gonna turn on the weather radar. Maybe we can use that to avoid some weather, you never know. Just like to keep it simple. So now we have to turn in Mount Pampas. Again, I'm gonna align the heading buck and make sure that I'm on my way. So let's pretend now that air traffic control has given us a new flight level. Climb to flight level 130. Okay, so I'm gonna select flight level 130 as the next altitude. In this case, in this aircraft, I'm gonna hit altitude intervent. But if you're flying a general aviation airplane or flying manually at this stage, you just climb yourself, right? Just make sure you adhere to the restrictions that are given by the charts on the SID plate or by ATC. So 13,000, and we can climb further. There we go. And in the meantime, we can enjoy some of these beautiful rainy skies over Amsterdam. So guys, as you can see, this part of the departure is pretty busy. You have to do a lot of things at the same time. The takeoff process, you have to follow the route very carefully. When you're in VATSIM, you also have to talk to ATC and switch frequencies. And when you have to do that all on your own, that's quite a busy task. In the real world, they do it with two pilots, of course. So, and the one pilot will fly the aircraft, and the other pilot will do the air traffic control communications, which is a bit easier, to be honest. Just make sure you practice this offline a lot, alright? I can't stress that tip enough, alright? So now let's pretend that you receive a direct. And a direct just means, hey, I want you to fly direct to this waypoint because this makes your route shorter and it's possible. Usually it's not possible because there's other traffic around, or the air traffic controller just wants you to complete the SID. But when you're flying a SID or when you're cruising on your route, you can expect a direct to a waypoint. So let's just pretend that air traffic control clears us to a waypoint. For example, they might say proceed direct Bedum or whatever. Okay, I'm gonna direct Bedum. So in this case, I'm gonna open up the flight management system. I'm gonna select Bedum, and in this case, I'm gonna put it in the first row of the legs page. As you can see, it draws a line on the navigation display, and we're just going to fly direct to that waypoint. This is how it's done in the Boeing 737. For your aircraft it might be a bit different, but just so you know that air traffic control might give you a direct, so make sure you know how to do that in your aircraft. So as you can see, within the flight management system, this is very easy. That's why it's so important to have an add-on airplane with up-to-date AirRock data. But it's going to be harder if you have no up-to-date data or using the default GPS system. Actually, this is the most easy way to do it, and you can also see the vertical profile right now. So we're just going to climb further. Let's say the air traffic controller cleared us to flight level 370 directly, so we don't have to adhere to the 130 as restriction anymore. We could just continue to climb to flight level 370, and the VNAV system will do the rest of the work basically. At some point we'll reach our top of climb. You can see on the progress page when that is. So that's at 14:48 Zulu, so that's 14 minutes, and it's 96 nautical miles away. So you kind of have an idea when the next, or when you have reached your first cruise altitude. Alright, so let's just say we've progressed into the flight. I've selected a little bit more daytime right now, so that's why the time has changed a little bit. But anyway, the point, at some point of course you want to descend, and the way that's indicated in the Boeing 737 and many other airliners is by a top of descent point. So at this point VNAV system actually wants to descend. So in this case you would ask air traffic controller for descent, or he or she might already have given you a lower altitude, and you just select that lower altitude here in the MCP, and the VNAV system should automatically start its descent. Alright, Now, of course, you want to be flying some kind of approach to a runway. We're going to fly an ILS approach to runway 18, as in my VATSIM full flight that I did. And the basic idea is that we are going to show you how to tune an ILS and how to fly that ILS. That's the bare minimum that you need to know. Of course, in the flight management system, you also have to select the star and approach in the FMC. So let's take a look at the chart right here. So as with the standard instrument departure, we're just going to cross-check with the chart whether everything is correct. So I selected the Orvix to Alpha arrival. So we're going to fly inbound Orvix, then to the SMARTA VOR, which is identify Tango Uniform Kilo, which is correct, and we have to be at that altitude at 9,000 or at that VOR station at 9,000 or above. That's also indicated on the FMC, so that's alright. Then we proceed to the Gudin waypoint, and then we can move over to the ILS chart, where we're gonna fly the transition here at Gudin. As you can see, Gudin 2500 or above as well. That's also in the FMC, and then we're just gonna fly and inbound to the ILS on 178 degree course. Alright, so what you want to do is tune the ILS. I'm just gonna show you how that's done. The way you can get the ILS frequency is off the charts. So in this case, the ILS frequency is 111.1. You can also take a look at the init ref page in the Boeing 737 FMC. You can see here all the information. And in other airliners you don't have to tune ILS at all, but in the Boeing 737 you still have to. So the main principle is that you tune in the ILS frequency right here in the nav radio, 101.1. Make sure that it's active, and then also put in the course here. So the inbound course to the runway, which was 178. As you can see on the chart, 178 is the inbound course to this ILS, and that's basically what we're gonna fly. So as we get closer to the ILS, I can show you in more detail how that works, and then you can do some other things that are also discussed in the charts video, like tuning or selecting in minimums for this approach. So let's just put it at 231 barrow altitude here. So we're aircraft category C, and we're going to fly in a Cat 1 approach. Let's just put it at 200 or 231 barrow. So that's the altitude above mean sea level. So as you can see, we've now started our descent. The aircraft is descending itself. What the Boeing 737 will come up with is this flight path indicator showing you the deviation from the desired flight path. And if you have entered all the data in the flight management system correctly, such as the route and all the weight, then this flight path indicator will give you a good idea of your desired flight path. And if you're too high, you can add some speed brakes to increase the rate of descent, or any other form of drag, for example by adding flaps or even a gear. But usually the speed brakes are used at higher altitudes, of course. And if you're too low, you might want to switch to vertical speed mode right here on the MCB, which allows you to kind of reduce the vertical speed so the airplane doesn't descend as fast as it wants to, which gives you more hands-on control on the rate of descent. So just make sure you know those options are out there, right? So let's pretend we're now passing flight level 317, but air traffic control already clears us to flight level 90. And let's pretend that the air traffic controller gives us a direct to a VOR station. Now, being able to navigate to a VOR station is actually something that you have to learn. In the 737 and on the other airline within flight management system, it's very easy. Just as with any direct, you just select that VOR station, so Tango Uniform Kilo, or you can type it in even if you want to, so Tango Uniform Kilo, and then put it right here. In this case we can just select it because it's already part of the route. We just select it here, and then we can fly direct to that VOR station if we want to. Alright, and basically any waypoint that's on the chart of your star chart are waypoints that you can expect a direct to. Alright, so don't freak out if you suddenly hear a VOR station that you've never heard of. For example, Amsterdam. When you approach Amsterdam, they might give you a direct to the Spijkerboor VOR. You don't know what it is. Just, before you start your descent, review the approach plate, so you know kind of what VOR stations and waypoints are in the neighborhood that you can expect a direct to. Alright. So as I was talking about VOR, you can just use the direct function in the FMC. But another way, a more conventional way of flying direct to a VOR, which especially happens when you're flying general aviation aircraft, is to actually use the navigation radio, like in the old days. Of course, when you're flying on VATSIM with the 737, you don't do it this way. But I just want to show that to you so you know how to do that, at least in general aviation airplanes, right? So let's just pretend air traffic control wants us direct to the SMART VOR, the Tango Uniform Kilo. You can see the frequency right there, 112.3. So let's go over to the navigation radio and select 112.3 right here. Put it to active. And as you can see on the navigation radio, we already see some indications. This green arrow points to the VOR station, and you can see it already here. And then here we have the radials from that VOR station. So if I turn the course knob, you can see how that radial changes. So let's say air traffic control might instruct us to fly inbound to the Tango Uniform Kilo VOR on a certain radial. For example, on radial 260 maybe, or 250 or 255, or inbound course 075. Okay, so a radial is always going from the VOR station, and you track a course to the VOR station. So this radio, as you can see here, 255, is from the VOR station going this direction, but we want to fly to the VOR station. So we're going to fly 255 minus 180 degrees is 075 inbound to the VOR station. Alright, so this is the conventional way of doing this. So let's say air traffic control instructs us to fly inbound to the Tango Uniform Kilo VOR on a 075 inbound course, or the 255 radio. So we can use the VOR mode on the aircraft right here, and as you can see, this is the radial that is portrayed, and this shows you your deviation. So this is the aircraft, and this shows the radial. So the closer we fly to this VOR station, and the closer to this radial, the more we're gonna catch up with that radial. Alright, gonna arm the VOR lock mode on the aircraft. It's still on LNAV, and I can probably show you on this navigation display how this all looks. So the aircraft is now on VOR lock mode, so it's tracking this 075 inbound course to this Tango Uniform Kilo VOR. So if I display this on the first officer side, can I have a better idea of what that looks like. So as you can see, we're now flying inbound to the Tango Uniform Kilo VOR, and we're gonna catch up with that radial. Alright, so that's kind of the idea of flying direct to a VOR station. So now let's say we're being vectored. For example, we're flying on heading 060, and the air traffic control wants to let us fly the 100-degree inbound course to the SMART VOR, the Tango Uniform Kilo VOR. So just another example. So we just have the navigation display open. I'm going to turn the course knob to 100 and make sure that the VOR station is tuned. And once we pass this radial, we'll be flying inbound to the Tango Uniform Kilo VOR. Okay, so I'm just going to arm VOR lock mode again. There we go, VOR lock mode is armed. And once we approach that radial, the aircraft will automatically fly itself to the VOR station. If you're in a general aviation airplane, you will just make sure that you know that this radial is approaching, and then you make the turn yourself in order to establish that course of 100 degrees to the VOR station. But as I said, in the Boeings, it's pretty easy. You just select the waypoint as the first waypoint in the legs page, you hit execute, and we're just gonna go back to LNAV, and then we're gonna fly direct to that VOR station if air traffic control instructs us to do. But just so you know that you know how to tune the VOR frequency, how to use the course knob to establish a course to the VOR station or fly away from the VOR station, can also be done. And yeah, just make sure you're able to do that and intercept a certain radial if required. This same principle will be applied with the ILS approach, so we're arriving shortly, so I can show you how that works. Alright, so we're shortly going to be flying an ILS approach, and for an ILS approach, the kind of the same principles apply for flying direct to a VOR station, but now we also have a vertical flight path that we have to follow instead of just the lateral path to fly a specific track to the VOR station. Alright, so I'm leveling off the 2,500 feet. Let's just pretend we're being vectored by air traffic control. I'm going to reduce the speed a little bit to something like 220 knots, and this is also based on speed restrictions that you find on the chart or that air traffic control may give you. But let's take a look at the ILS approach. So what you want to make sure that you have in, I'm just going to increase the lighting a little bit for you guys. What you want to make sure is that you have tuned in the ILS frequency, which we found on the chart and in the FMC as well. So 111.1 is active, and we've entered the inbound course. So 178 was the inbound course to the runway. Okay, now air traffic control will now give us a vector, or we'll just be following LNAV at this point, could also be possible. And what they usually do is give you a heading that will allow you to intercept the localizer, which is the lateral part of the ILS. They will give you a heading to intercept that localizer at the 30-degree angle. So in this case 178 minus 30 would mean 148, but we can just round it up to 150, something like that. And this will give us a nice intercept angle for the localizer. Alright, so we're just going to keep a good eye on the primary flight display in this case. So I'm just going to reduce the speed so I can explain everything slowly to you. What you usually want to try to achieve is to fly about 180 knots on the base lag. You can kind of judge yourself what the base lag is, and then once you are cleared for the ILS approach, then we can fly about 160 knots until 4 DME, and 4 DME is the point where we're going to switch to the approach speed of our aircraft. As you can see, I've not selected them yet. You can just select them right here. So we're going to be flying our approach speed at a 30-degree flap angle and 142 knots, and there's a wind correction of 5 knots, so our final approach speed is going to be 147. Okay, just keep 160 for the time being. But we're just going to keep a good eye right now on the indications of the ILS. So what's going to happen? Alright, I'm going to add some flaps right here, so we can make sure we are at 160 knots. So in a moment, this ILS indicator, the localizer indicator in this case, the lateral part, will start to move. So it now indicates that the localizer is to the left of the airplane. And basically you can see the position of the airplane as this middle vertical line right here. And each dot on this scale represents 1 degree of deviation. Okay, so we're now deviating about 2 degrees from the ILS, and as you can see, we're slowly catching up. I'm just going to add more flaps in the meantime. And in your aircraft, you want to make sure that something like approach mode is armed. And as you can see right here, VOR lock mode is active, and the glide slope is, well, it's not active yet. It's in standby mode. It's indicated in white in the Boeing 737. So in a moment, the VOR lock mode will become active and will replace heading select. And as you can see, the localizer is now coming in. So let's keep a good eye on the primary flight display. The airplane is still flying itself at this stage. And as you will see in a moment, VOR localizer mode will be active, meaning that the localizer is being captured by the airplane. Okay? So there we go. We're approaching it. We're almost passing the localizer at this stage. And there we go. VOR lock mode is active. The aircraft is now establishing that 178 inbound course to the ILS. And you just want to make sure that the heading bug is also aligned at this stage, so 178. And as you can see, indeed, we're flying straight direct to Riga in this case. Now, for the glide slope, same principle, but then the other way around, so 90 degrees flipped, basically in the vertical plane. So in this case, the glide slope is coming up, and this indicates that the glide slope is now above the aircraft. And again, the middle line here indicates that our position of the aircraft, basically. It's now deviating about 1.5 degrees, and it's slowly catching up. And soon the altitude hold mode will be replaced by glide slope. Okay. And if you're doing this in a general aviation aircraft, you would just start your descent yourself, right? You would just make sure, using your manual flying skills, that you are following the glide slope and the localizer accurately. But in airliners like this will be pretty much automatic, okay? So, there we go. We're approaching the glide slope, and soon it will be captured, and we will be, there we go, we'll be flying on the glide slope. So, now the airplane is just flying itself all the way down to the minimums. At minimums we're going to decide whether we're going to land or not. Now, I do have to make a remark here. I did not update my scenery for this particular airport yet, and I know that this glide slope is way off, as you might have seen in my VATSIM video on this airport. But it doesn't matter, we'll just fly this ILS approach and see where we end up. Just so you know that, default sceneries are usually fine, but some add-on sceneries in flight simulation do not have accurate glide slope indication somehow, or they still have to fix that. It can happen at some airports, so just be aware of that, alright? So keep looking outside. In this case we can't see much outside yet, so let's see what happens. But I hope by now you have a general idea of how the ILS works, and also keep a good eye on your DME, right, so you know how to regulate your speed. You can also display the DME right here. So we're now 4.7 miles from the ILS, and I would have already put the gear down at this stage actually, and reduce the final approach speed. So 147, there we go, and 30 degrees of flaps. And then we'll take a look whether we can see the runway or not. We'll put the landing lights on, things like that. Of course, this is all extra information basically, but I just want to make sure that you know how the ILS works. That's the most important thing. And as you can see, the ILS is very important. Right now we can't see a thing outside, so having that ILS available and being able to use it properly is so important. Otherwise, at this stage you have no idea where you're going, okay? So just keep that in mind, that you need to know how to fly an ILS on the VATSIM network, otherwise you might run into trouble. Okay? Now, at this stage we'll just look for the runway. Actually the example is pretty good right now to use an ILS indeed, because the visibility is very bad, so we might even have to go around this if it's all way off. Apparently I already updated this scenery, or maybe I applied the fix for the glide slope. We can see the runway right now, so I'm just gonna switch to manual mode and fly the aircraft manually, basically, and land it manually. So we can fly an entire ILS approach manually as long as you see the runway. But if you're new to the VATSIM network, I would highly recommend to keep it on automation. Try to make sense of all the indications and things like that, so you know how to use the ILS. Okay. So I'm just gonna land the airplane right now, and there we go.
50, 40, 30, 20, 10.
Not the best landing. There we go. And we'll bring the aircraft to a full stop. So guys, that's the basic idea of flying an ILS approach and doing some of the navigation. So just keep in mind, relating to the ILS approach, tune the frequency, set the inbound course, look at the charts, and then you should be able to execute the ILS approach pretty well, at least as a beginner on the VATSIM network. So guys, I hope this video has helped you out. Just keep in mind that you really train offline with your aircraft first before you're actually going to fly on a VATSIM network, so that you already master all these flying, navigation and flight management system skills. It's really, really important, because you will notice when you're going to fly on the VATSIM network and you add communication to your flying, you will get kind of into a brain freeze where, suddenly you don't have any idea anymore what you have to do, because you enter a new situation, so you have to kind of get used to that. And by having those flying and navigation skills already before you fly on VATSIM, this process will be a lot easier. So thanks for watching this video. If you have any questions or comments, make sure you leave them in the comment section below. And in the next video, we're going to take a look at the fun part, what VATSIM is really about. It's about phraseology. So I'm going to show you the basic phraseology for an IFR airliner flight from A to B. I'm going to be using the Amsterdam to Frankfurt route as an example in this case. It's kind of a route that I also fly a lot, and I flew a lot when I first joined VATSIM. And I'm just going to take a look at all the phraseology and communication that is required for such flight. So that's it for this video. If you like to check out some of my other videos, make sure you do so. And if you'd like to support the Aviation Pro channel, you can check out the description for different ways of doing so. Your contribution is much appreciated. I will see you on the next video, and take care.